Hey you guys. Hey, we're working on a review of Unit 5, preparing for your test here. I'm going to go through each concept, do a few problems, and hopefully this will bring back some memories here. And here we go. Alright, concept 14, we want to look at ratios and rates. Here's a problem here. The boys to girls in a class is 3 to 4. If there are 24 kids in a class, how many girls are there? Then I'd like you to find 3 equal ratios to boys to girls. All right, here we go. First one. A couple of things you got to remember. If you want to write this down, we had 2 situations where we had a part on a ratio here. I went from a part, and it could be written as a part whole. So you have to look at the situation and see which ones I have, because I'm going to be flipping back and forth in between these two. If I look boys to girls, that's a part to a part. But if I tell you there's 24 kids in the class, that's a whole. So I have to do a little switch. I got to switch from the part to the part whole. So here we go. Again, the order is important here. It's not the order of the numbers. It's the order of the words. So that's the other concept you got to remember. It's the order of the words, not the numbers. Okay? So these are what you have to look at. Boys, that's the first one. That goes with the 3. And then girls goes with the 4. So I have 3 boys and 4 girls. That's my ratio, but that's a part. I want to go to a part whole, and I want total of 24. I need to find the total of this ratio right here of 3 to 4. So I have to add them up. 3 plus 4 is 7. Now I have how many girls? Because I want to know how many girls there are. Well, I have 4 girls out of a total of 7 kids here. Now I'm ready to set up my proportion here. How many is that out of 24? Okay. Then again, you cross multiply. So take 4 times 24. And then I'm going to have 7 equals 7x. So multiply that up. I'm going to get 96. 4 times 24, that's 96. That equals 7x. And then we're going to take 96 divided by 7. 96 divided by 7. So 1, 7. No, it's not going to be a very nice one. So 26, how many 7s go into 26? Well, that's 3. That'd be 21. So 21, 26, you got a remainder of 4. So I'm just going to round it. On your test or quiz, it'll work out nice. I was going fast. So if I have a remainder of 4, so basically I'm going to have, in this class, I'm about 13 girls. So to answer the question, I'm going to have about 13 girls. All right? Just remember, part whole. Let's find 3 equal ratios. All right, so if I got 3 boys, excuse me, 4 girls, treat equal ratios like equal fractions. So if I multiply top and bottom by 2, I'm going to get 6/8. That's equal. Okay, multiply top and bottom by 3. I'm going to get 9/12. That's equal. And then multiply top and bottom by 4. I'm going to get 12/16. And all of those, they're all getting all together here. But these are 3 equal ratios. 12/16, 9/12, 6/8 are all equal to 3/4. Okay, and that's how you find equal ratios. The other thing you can look at is if you reduce all of these down, they'll all reduce down to 3/4. Or if you divide them, if I divide them, they'll all divide to the same number. That will kick it to a unit rate. And that'll be all the same. It'll be 0.75 if I divide these. All right, let's move on. Which is the best buy? A 2-liter pop for $1.80 or a 12-liter for $8.40? Now you can use your calc on the test. So remember, money always goes first. You always want to put that money first. and I want to find the best buy. So I want to find the price per, again, remember per means to what? Yep, you remember, per means to divide. So they tell you right here how to do the problem. Take the money divided by the ounce. Just remember, money always goes first. So if I take $1.80 and I divide that by 2, just cut it in half. If I take $1.80 and I divide that by 2, that's going to be 90 cents. Okay, so for this one right here, it's going to be 90 cents per liter. All right, so that's the unit price. Now I'm going to take this right here and I'm going to punch in $8.40 divided by 12. Well, put my decimal point. How many 12s go into 84? Well, that's 7. 7 times 12 is 84. Now, so I'm going to add a 0 here quick. And then that's going to be 70 cents per liter. So which one's the best deal? The cheaper one is 12 liters for $8.40. All right, let's move on to the next concept. 15, we looked at proportional relationships. All right, I want you to find out, is this table of values a proportional relationship? If it is, then let's write the equation. All right, well, we want to look, and what you want to write down when you think of proportional is this. I'm going to have some constant or some number, we're going to put k, times x. So this is a proportional equation. Or if you want to put a number in, it's going to be like 4x. That's proportional. Now you got to remember, if I move this x, if this is multiplying, and I want to move my x to the other side, if I'm multiplying here, what am I going to be doing on the other side? I'm going to be dividing. This is the other equation right here. So these two, you want to remember, these two equations right here are proportional equations. Okay, if it's solved for y, I'm going to take some constant times x. But if I move the x over, it's also going to be y divided by x. And this is what I want to look for on my table. If I take the y divided by the x, are they all going to be the same k, all the same number? So if I take 5 divided by 2, 10 divided by 4, 15 divided by 6, 20 divided by 8, if you take a calc and divide all that, so if I take 5 divided by 2, you remember you have to take the y divided by the x. That goes in there twice. That's 4. And you get 1. Bring a decimal point. And then 10, how many 2's go into 10? 5. So if I take 10 divided by 4, that's 2.5. 15 divided by 6, 2.5. They're all going to divide to 2.5. So is this a proportional relationship? Yes. How do you know? You take the y divided by the x and see if they all come to the same one. So what would the equation be? It's right here. Here's my unit rate right here. Here's my constant. Here's my k. So for this one, what's my equation going to be? Y equals, see if I can make a little nice y there, equals 2.5 x. So for every value, all these x's, if I multiply them by 2.5, I'll get these numbers down here, my y values. All right, now let's look at the next one. What does the graph of a proportional equation look like? Well, it has to be two things, and hopefully I'll be able to, dent. I couldn't get it. So what does it have to do? Oh, it's close. Let's say it goes through the origin. It has to be two things. It's got to be a straight line. So it's got to be a straight line. Just trying to go quick. It's got to be a straight line, and then it has to go through the origin. So it's got to go through 0, 0. All right, that's easy. That should be an easy question on the test. All right, let's look at the next one. If Austin has $6 per hour plus $10 in his pocket, would the money and the hours be proportional? All right, and then what does the equation of a proportional, what does it look like? All right, let's look. $6 plus 10 in his pocket, this isn't going to be proportional right here, because you cannot have anything added on. So the equation would look like this. He gets $6 every hour, plus he's got $10 in his pocket. This is not proportional. Okay? So what would proportional look like? If I took the 10 off, if I cross this out, if you made $6 an hour only, 6x, now we're talking proportional. Okay? So it's got to be in this relationship. Or if I move the x over, you could see it written like this. You could say y divided by x equals 6. It may look like that as well. All right, let's keep moving here. 2 more to go. Is the table of values, is this inversely proportional? If it is, write an equation for it. Now, inverse, we got to think of the other way. So inverse is going to be some constant divided by x. Okay? Or if I move the x over to the other side for the checking for the table, if it's dividing here, what is it on this side? It's going to be division. Okay, or excuse me, if it's dividing here, it's going to be multiplication over here. So this is going to be inverse too. So if I take my x times my y, write these down, these are going to be inverse, because I'm going to divide. When this gets bigger, and if I divide, it's going to get smaller. We've talked about that. If you look at your x is getting larger, this one actually is going to get, doesn't look like it, it's going to get smaller. Well, it doesn't look like it's going to be a inversely proportional relationship, because let's look, multiply them. What's 1 times 1? Well, that's 1. What's 2 times 5? That's 10. All right, I can tell right now 24. This isn't even close to being a proportional relationship. Okay, so let's say I do have one. Let's draw one up. What would be a proportional or inverse relationship? So what would it be a graph of an inverse? Well, they just have to multiply to the same number. So let's say I pick 12. I could multiply these to 12. So I could say 1 and 12, 2 and 6, 3, there's a 6 right there, 3 and 4, multiply to 12, 4 and 3, I can flip it, and let's go to 6 and 2. So all of these multiply to 12. If I take x times y, they'll all multiply to 12. All right, so what would that equation look like? Oh, that would be my constant. 12 is going to be my constant here. So I'm going to say y equals, right up here, 12 divided by x. So if I take 12 divided by all these numbers, I'll come back up with these right here. So this is an inverse equation. This is an inverse table. Okay, this is not. All right, what's the graph look like? Well, real quick, it's not a straight line. It's actually going to be a curve. Okay, it's going to be a curve. All right, that one's easy too. It should be a quick, easy point. If a candle burns, or excuse me, the longer the candle burns, the shorter the candle gets. Would the time and the length of the candle be an inverse proportional relationship? What does the equation look like? All right, so what happens is one getting bigger as it gets longer. As the candle burns longer, the longer it burns, the shorter it's going to get. So I got my length right here. So if I burn it longer and longer, that's going to get smaller and smaller and smaller. All right, that's going to be an inverse relationship. So this is yes, that's inverse. What does it look like? Well, we already talked about it. It's going to be y equals some number, let's use 12, divided by x. Or if I bring the x over, I'm going to say x times y equals 12. All right, we already talked about that. On your quiz, you had to be careful because a couple of you missed it because you had this. This isn't inverse. You had x divided by 12. You thought if it's division with a 12, that's going to be inverse. No, the x, this is not. The x has to be on the bottom down here. Not the 12, the x has to be down here. All right, let's go to our last one quick. This is slope, rate of change, find the slope from the table, and write an equation. All right, remember how to find slope. Okay, there's a lot of definitions. It's the change in the y. Trying to go quick, so I'm not going to write it all out. Change in the x, or it's the rise over run. Those are the definitions you got to get memorized. Okay, so I want to find change. Remember, the y goes on the top, and the x is going on the bottom. Remember that. So let's look. What's my change here? So remember, we use these little symbols. This greater than, less than, from 1 to 4, 4 to 7. That's a jump of 10 every time. Or a jump of 10. A jump of 3 every time. What's my jump in my x? My jump in my x is going to be 1. So I'm jumping 1 here. Now what's my slope? It's not 1/3. Remember, your y goes on the top. It's going to be 3 over 1. And we want to reduce our slope if we can. That's going to be 3. So the slope of this table is 3. What's the equation? Well, if I go back now, this is the tricky part. I got to go get my starting point. I got to go back and find that 0 for my x. Well, if I continue to back up 3, I got to go back 3 now. Okay, so I'm going to, instead of going up, I'm backing up 3 from 1. Well, if you do that, you're going to end up with -2. Okay, so that's my starting point. So now I can write my equation. Remember, y equals your slope times x plus b. Remember, this is slope-intercept. So if I write my equation, I'm going to have y equals my slope right here, 3x, plus my starting point, which is -2. So I write -2 for a -2. There's my equation for this line right here. If I plug in 4 right here, take 4. That's my x. If I put 4 right here, 4 times 3 is 12. 12 minus 2 gives me the 10. Put 3 here. Put a 3 in. 3 times 3 is 9. Take away 2. That's 7. Okay. You can always check it by plugging them back in. Okay, what's the slope of the line that passes through here? And let me erase a little bit here. All right. What's the slope? Well, I want to find it in the change in the y on the top. Remember, the y goes on the top and the change in the x. So think of temperature. If I'm at 2 above and I drop to 6 below, that's a change of 8 degrees. All right. How about my x? If I'm at 4 below and I rise to 2, so 4 below up to 2, it's going to be a gain of 6 degrees. So I'm gaining 6, so my change is 6. So that's going to be -8 over 6. If I reduce that down, I'm going to get -4/3. Okay. Now, what if they want the unit rate? If they want the unit rate, then I'm going to divide this because I want to take this down to 1. Then I'm going to take -4 divided by 3. And I'm going to get -1.3 repeating. That's going to be my unit rate if they ask for the unit rate on the test. All right? Or some of you, if you take the y2 minus the y1, so I take my second, if I take -6 minus 2, and then I take, if you start with the 6, you got to start with the 2. So I take 2 minus -4, boom, boom. I'm going to get 6 on the bottom. And then if I go boom, boom, that's a -2. I'm going to get -8 on the top. Either way, you can subtract the y's and you can subtract the x's. That'll give it for you as well. All right, a couple more quick. What's the slope of the line? Again, we're finding intersections, so there's an intersection. Here's the next one. I'm going to rise 1, but I'm going to be careful. Don't say 2. You're backing up 2, so you got to put a -2. And your rise goes on top. So if I'm given this, that's going to be a slope of 1 over negative 2, or I always move the negative to the top, negative 1/2. That would be the slope of this line. Watch out, it's dropping. So be careful on the test. If it's dropping, it's going to be negative. All right, one word problem here. We're almost done. The speed of a bug on a rug is shown in the graph. Okay, how far will the bug travel in a minute was the equation of the line. All right, so here we go. I got this bug here, and I want to find the slope. So I'm going to try to find an intersection here, and I got one right here. So he traveled, what is it? 10 centimeters in 5 minutes, and I keep trying to find my other intersection. It's right there. So you got to be careful now, because you can't count 1, 2. Okay, be careful on the test when you do this. This is not 1, it's 5 and 10. So this is a rise of 10. Make a note, you guys. You got to be careful, because it's not always 1. Now if I'm going this way, now I'm back to 1. So 1, 2, 3, 4, 5. Okay, so I'm gaining 10 centimeters in 5 seconds. So I'm going to put the rise, though it change in the y, over the run. And if I take 10 divided by 5, I'm going to get 2. Okay, and this is a proportional. So the equation, you can see it's written right there, equals 2 times x. Because my starting point is what? What's my starting point? Yep, it's 0. So I'm going to say plus 0. Well, you don't have to put plus 0. So we just write y equals 2x. Now, how far is he going to go in a minute? This is in seconds. Right? Well, I know he's going to cover 2 centimeters every what? 2 centimeters every second. So if I go 2 seconds, you can make a proportion if you want. 2 centimeters in 1 second. Now you can say, okay, so how many is in a minute? Well, I don't want to put 1, I want to put 60. I want to go apples, apples, oranges, oranges. I want to go centimeters, centimeters, seconds, seconds. And then all you have to do is multiply right here. 2 times 60 divided by 1. 2 times 60, that's 120. Well, if I divide that by 1, that's just the number again. So I'm going to get 120 centimeters. Okay, that's how far he's going to travel in a minute. So you can just make a proportion for this one. Or you can just multiply it by 2. Get 60 times 2. Don't use 1 minute, because remember, these are seconds. Alright, good luck on your test. Catch you later. Ask if you got any questions.